Okay, so in this teaching worksheet, we are exploring two types of linear inequality question. The first type is like this kind, example 1, where you are given a range of x and y, and then you're supposed to find the greatest or the smallest possible combination. Okay, so the way to approach, there's a little bit of trial and error for this kind of question, but there's also a proper approach to it. So for example, when we see things like this, don't just look at it in this way. So usually I will list out. So be careful of the equal sign, whether there's the equal sign or not. So usually I'll prefer to list it out. So when they give us a range, right, don't just stare at the range. The reason is because if you stare at the range, most probably you're going to look at -4, you're going to look at 3, you'll look at 1 and 6. You will miss out on other values that you are able to use. So for the valid values of y, it will be 1, 2, 3, 4, 5, 6. And if you list it down, you will also try to be mindful about the equal sign. Okay, so after I list down, then I will be answering the question. So for example, part A, greatest possible y minus x. So you will like the greatest difference. So you got to think a little bit. So this one you want to be as big as possible. And for x, you would like to be as small as possible. So if you think this way, then you'll be using a 6 minus -4. So that will give you a 10. So that will be the greatest difference between y and x. Okay, the next one, B, you want the smallest. So whenever the question asks you for the smallest, your thinking must be as negative as possible. Very negative number will be very, very small. So you got to choose a very, very negative number. So in this case, right, for x, I will choose a -4. Okay, y doesn't have a negative number. But then, right, if I choose the biggest possible y, then that's a -6. So if you take a look, it will give me a very negative answer. So whenever you're supposed to find the smallest, you must think of getting as negative as possible. So for part C, we want the smallest product. Again, you have to think, you want to be very, very negative. So how negative can you get? So I will choose a -4 and a 6. Because when I do this, I get a -24. And you can see whether you can get even more negative with this or not. Okay, then let's go to part D. D, I would like the greatest. The greatest x squared plus y squared. Okay, so a lot of people, right, when they want the greatest x squared plus y squared, okay, most people will choose a 6 square. That will be correct. But some people will choose a 3 square for x. So that is actually wrong. Because if you square a negative number, it's actually a positive number. So here I will get this equal to 52. Versus if let's say a student is not careful, right, a student will get this, which is in fact smaller. Okay, so that one will be a common mistake that some people will do. So they just think I want the biggest x and I square the biggest x. You should think about even squaring the negative number. Okay, when it comes to fraction, greatest x over y. Okay, if you want the greatest, that will be as big as a whole number as possible. Okay, so in this case, right, if I choose, okay, I will choose a 3 over 1. That means I'll choose x to be 3 and I'll choose y to be 1. I wouldn't choose a 3 over 6. Some students will choose a 3 over 6 because they just choose the biggest one. But if you choose a 3 over 6, that means you're actually getting a half. Okay, so you need a bit of sense when you're doing this kind of question. Okay, for part A, it's a normal solving. When you solve, you should get 2 possible answers. So I should get a positive 4, I should get a minus 4. Then you got to go back to the range of x to see which one is valid. If you go to the range of x, you realize that x can be a negative 4, but 4 is not inside the range. So you actually got to reject. Okay, and one thing, sometimes, right, another thing to take note will be, sometimes the question will ask for this. The question will ask for the smallest x squared plus y squared. So for the smallest, sometimes some students will do something like 3 squared plus 1 squared. Okay, so but then, right, if you look at the numbers, right, 0 square is actually the smallest. So sometimes we might forget to use 0, especially if you don't write out the range of the numbers that's given to you. Okay, so sometimes 0 can be in use, so you just have to take note. Okay, so this kind of question, you got to play around with it, but you got to use some sense. So it will be best if you list out all the possible values first. Okay, so from example 2, example 3, example 4, we are going to do the problem solving in inequalities. Okay, so there must be inequality that you form. So it cannot be doing like primary school method, or it will be very basically close to algebra. Okay, so let's read the question first. In example 2, okay, example 2, okay, Jack is sitting for 3 tests, and the third test is the unknown one. And then he wants an average of at least 80 marks. So this is to tell you the symbol. At least means greater or equal. So there are some specific wording. So if the question is like at most, that means it's less than or equal. Okay, if it's more than, then of course it's just greater. If it's less than, of course it's just less than. Okay, so the sign can be very tricky. The moment you use the wrong inequality sign, you can actually get 0 marks for the whole question. There is no method mark. Okay, so in this question, we are dealing with the marks in the third test. So I'm going to assign the algebra. So let X be the mark in the third test. And I'm interested in the average. So I need to get an algebra expression for the average. So there are some amount of algebra involved. That depends on the question. In this question, I need the algebra for the average. So later on, subsequently, there's also other algebra that we need in the question. So we try to simplify the algebra. And then now we break down this average. So the average refers to the algebra. The word at least means greater or equal. So that's how I form the inequality sign. After you form the inequality sign, you solve as usual. You solve as usual. but you must remember to answer the question. So after you solve as usual, that means, right, what is the lowest mark? So the lowest is 83 marks. If you couldn't tell from the inequality, you draw your number line. You draw your number line. So this one, if you draw with the number line, there should be a black circle at 83. So the lowest mark is 83. Okay, so you do as usual. Okay, so in this question, we form the algebra for the average mark because we are dealing with the average. Okay, and in the next question, okay, it's something to do with money. So Claire would like to make a fruit salad with mangoes and peaches. So we know the cost of a mango, we know the cost of a peach. So she has not more than $25. That means, right, she can spend $25 or less. She doesn't have more than $25. That means she can spend $25 or less. So what are we interested in right now? We are interested in the cost of the mangoes and peach. So there's a little bit of quantity times price. So she has to buy 15 fruits. And we are interested in the maximum number of mangoes. So I will let X be the number of mangoes. And because she needs to buy in total 15 fruits, if X of them are mango, then 15 minus X will be the number of peaches. So that will be the quantity of mangoes and the quantity of peaches. So we use the concept of price is the amount of money is quantity times price. Okay, I'm sure you heard me mention about this idea before. So how much to spend is like quantity times price. So what is the cost of the mango from the X mango? How much is the cost? Again, we do a quantity times price. The quantity is X. The price is 180. So it'll be 180 times X. Let's find out the cost of the peaches. Again, it's a quantity times price. So the quantity times price will be 120 times the quantity, which is 15 minus X. So we would like to find out the total cost because the total cost is limited by the $25. So the total cost will be 1.80x plus this. So you can do some algebra. So 1.80x, you can expand out the bracket. You will be getting something like 0.60x plus 18. So that's actually the total cost. Total cost of the mangoes and peach. So with the total cost, she's limited by the $25. So as long as the total cost doesn't exceed 25, that means she still keep to 25 or less, then that will be sufficient. So I'm going to do my inequality based on the equal sign. Do as usual. Okay, so do as usual. Solve as usual. So whenever you are solving, you're finding 1x. So, and then you can draw your number line. So when you draw your number line, of course, you got to choose the nearest whole number. because the number of mango doesn't come in half of that. So it has to be a whole number. So from the number line, x is 11. So to answer the question, the maximum number of mango that she can buy is 11. Because mango is the more expensive one. So how many can she buy? So with the limit of $25, she can buy maximum of 11. Of course, she can buy lesser and she's still within the budget. So we talk about the highest possible number of mangoes. So this question deals with cost. So that's why our algebra is like the money. So when it involves money, again, there's the quantity times price. In the next question, we are dealing with parameter. So such question, we can also be dealing with area. It depends. So in this question, okay, we have a rectangle. Okay, you might note down the length first. We got a square. And we are actually interested in the parameter. So I'm going to do my algebra for the parameter of rectangle first. So it's 2 length plus 2 breadth. So you are free to work out the algebra. The algebra is also quite easy. So that will be the parameter of the rectangle. So you look at what the question is like asking for. If they mention about parameter of rectangle, of course I must get the algebra for the parameter of rectangle. And in this case, I also need the parameter of the square. The next thing is to translate the parameter to an inequality. So you got to be mindful how to translate. So if you look at this question, parameter of the rectangle, so that will be 6x minus 6, is at least means greater or equal 12 centimeter greater than the parameter of a square. So that's my translation. So I translated what they say. The parameter of rectangle. So the parameter of rectangle referring to 6x minus 6. Then 12 more than the parameter of the square. So I add 12 to the parameter of square. And then because they say at least, then it should be greater or equal. So from here, I simplify my algebra. So do like how you usually do. All the algebra on one side, all the numbers on the other side. So if you draw a number line, the smallest x is actually 5. Okay, I'm looking for the smallest x because the question asks for the least possible parameter of the rectangle, which is this. So I should find the smallest x to use for the least possible parameter of the rectangle. So that will be 6x minus 6. Put the smallest x in, and you get the smallest possible parameter. So it behaves very much like our normal algebra, except that we got to set up with the correct inequality sign.